All right. Good morning, everybody. This is a real thin class today. I don't know. I guess it's midterms. Yeah, I guess it's actually midterms time. Well, thank you all for coming out to catch up with me on software development. I forgot to do this with you on Tuesday, and so I'm gonna apologize. But I started the Gramapocalypse without you. I did this with the afternoon class, and you might have noticed that there's something going on with our cookie there, and that number two, our grandmas are terrifying. And our cookies are red. I'm really happy that popped up. Gosh, yeah, our cookies now can do bad things when we click on them. I'm gonna buy this exotic nuts. But these things here, these are called wrinklers. They appear when the Gramapocalypse starts to happen, and you can see that our cookies per second has been reduced by some amount. And when I click on these enough, they explode into cookies. And so my milk is changing color here as I'm exploding these wrinklers. But I'm getting all the cookies that they ate. So I'm getting lots and lots of cookies, and we've got like quadrillion, and we've got this, we've baked 100 quadrillion cookies in this one ascension. We can buy some upgrades here, I think, that's worth doing while we're sitting around here. And we've got chance makers, prisms, antimatter condensers. We've got lots of stuff to do here for upgrades. But our grandmas have gone kind of terrifying here. Anyway, back to actually talking about core stuff. Let's talk about core stuff today. So what I would like to accomplish today is I want to finish up the SQL stuff in TypeScript. I want to do just a little bit more with this in terms of showing some more kind of complete examples of the kinds of things that you might expect to do in your own projects. And then after that, I want to step into thinking about security. The security stuff that we're going to be thinking about in this course, just to give you some scoping, is not going to be in a great amount of depth. We're going to be looking at security from a sort of superficial perspective. There's a specific thing that we will want to protect against in this course, but what I would say is that if you are interested in security, there are courses that are offered in our department at the 3,000 and 4,000 level about security. There's 2 computer security courses, and they will go into a great deal more depth about this. So this is like 6 full credit hours of security related concepts, as opposed to like 1 class that we're going to be talking about it. In terms of the other thing that we're going to be talking about for security for us, the keyword that I'm going to throw at you right now is hashing. This is what we're going to be thinking about, but it's like we're not talking about hashing in terms of how it works. It's just this is a good tool for us to use. Hashing is a concept that would be covered in the 4th year cryptography course if you want to know a lot more about how hashing works. You've probably seen the word hashing if you've taken Comp 2140 before in terms of hash functions related to hash tables, but we're talking about cryptographic hash functions, which are a little bit different than the kinds of hash tables and hashing functions that you'd use for that. So by the end of today's lecture, what I would want you to be able to do is to continue to be able to use a programming language to interact with a database. So today what I want to be able to do is I want to be able to do finding data based on user interactions and adding data based on user interactions. So we're going to add new data, and then we'll be updating data as part of this. I want you to be able to use tools such as prepared statements to prevent SQL injection attacks. And so we're going to look at what SQL injection actually is. I want to do SQL injection properly today, and then we'll look at some solutions, and we're going to finally settle on this idea of prepared statements. I want you to be able to begin to identify the kinds of risks associated with storing user data or information. And so for this, what I want you really to be able to do is begin to identify the kinds of data that you'd actually accept as input. And this is more broadly than the kinds of things that we're talking about. Like in class, we're putting in Pokemon, and this is not sensitive data at all, but I want us to think more broadly. When I'm using an app from the App Store, what kind of data am I giving up to that? When I'm interacting with my bank, what kind of data am I giving up to that bank? And they're putting it into a database somewhere. So what kinds of things are we putting into that, and what kinds of risks are associated with storing that information? And then finally, what I want to be able to do is securely represent and store credentials for authentication purposes. So while this point here, identifying the kinds of risks associated with storing user data and information, this is really broad. This is all kinds of information that we might accept about the people that are using our software. The thing that we really focus on for this course only is going to be about credentials, so usernames and passwords. How do I identify myself to the software that I'm working with? So what I want to do first here is finish up this example that we've been working on for getting SQL into our app. And the very last thing that I want to do here is add some features that will save our Pokemon as we're adding them. So one of the things that we've been doing with this app is we've got this list of Pokemon. I click this button, the dialog pops up, it adds it to that list. I can click that button again and it will add new Pokemon to the list. But we don't save them right now. We're not persisting these Pokemon to the database. In addition to not saving them, we're not loading them from the database because that doesn't exist. We're not actually putting those records into the database. So I want to do both of those things. I want to be able to, as we add new Pokemon to this trainer, I want to be able to put them into the database. And then when I refresh the page, when I get this information back from the database, I want to load that data for that specific trainer from the database. So I'm going to be working in the repository that we have been working on for the last little while. I pushed up the changes that we did from last class. So if you want to follow along with what I'm doing today, please make sure you've pulled what we've got. But I'm going to start working through some of this stuff. And I'm going to try to work through it such that we're stopping and pointing at the parts that are related to the things that we've been doing before. So thinking about these ideas of things like async and await, and this idea of a little bit of concurrency, and this idea a little bit of promises, and how things are working with the stuff that we've got. All right, so the very first thing that I want to do is I'm going to go actually to my Pokemon class here. I want to start adding some functionality to this that will allow me to save my Pokemon. I want to persist my Pokemon to the database. Before I keep going, if you're further at the back, is this big enough for you to see okay? Yes? Okay, awesome. Thank you. So the first thing I'm going to do is I'm going to start writing a save Pokemon method, just like I was writing a save trainer method. So I want to give the responsibility of saving the Pokemon to this class. This is the Pokemon class, so it's going to know about all of the internal private properties of the Pokemon type. This is the right place to put that method. So to do that, I'm going to start adding to my class a static method here. This is going to be an async method, just like all of the other database interactions that we've been doing. The async and await keywords are, in the scope of this course, only ever going to be used really in the context of database interactions. I welcome you to learn more about them if you want and use them to do things like stage setting up your user interface, but I only really care about us using it in the context of interacting with our database. So this is going to be a static async method. It's going to be called save Pokemon. And what I want to accept as an argument to this is the Pokemon that we want to save. And what this is going to return is a promise of type Pokemon. So the pattern that I will typically be using for these kinds of methods is that they're going to accept something as input and they're going to return that same thing as output. I'm going to take this Pokemon in and I will make changes to the Pokemon that you've passed to me, but I'm also just going to return it to you again. Often, and especially in this case, where we have a synthetic ID or a synthetic key for the class that we've got, I'm getting that synthetic key from the database. And so I want to make changes to that class and I want to return it back to you so you know what that key is in that thing that I've made changes to. So I'm going to have this save Pokemon method, And what I'm going to do here is I want to say let results is equal to db. So db is the connection that we're going to have. I'll have to import that. And this is a relative directory from this connection.ts file. I want to say that I want to await for this. And I'm going to say exec. And I'm going to use string templates again here. String templates in JavaScript, remember, this is backticks. And so this is not single quotes. This is backticks that I'm using to do this. And when I'm inserting a Pokemon into the database, I'm going to say insert into Pokemon. The things that I want to insert into this are an ID. I'm not going to insert the ID. It's the responsibility of my database to do this for me, but I want to insert it because I want to get that field back out again. I'll describe exactly what I mean by that in a moment. I want to insert into Pokemon an ID, the nickname, the HP, and the trainer that owns this Pokemon. So Pokemon is owned by a trainer. The relationship that we have in our classes right now is that the Pokemon has the trainer has an array of Pokemon, but in our database, this has to be inverted. And so our Pokemon has to be owned by a trainer. This is going to require us to make a little bit of a change to this class. We have to know what our trainer is internally so that we can populate this field. And we'll do that in a moment, but I want to finish this part up. I want to insert into Pokemon those fields or those columns. And what I want to insert is values. The first thing I'm going to put here is the word default. This is a bare word. I'm not putting quotes around this. This is corresponding to that ID column. And what that is saying is, I want you, database, to please populate that for me. I'm not going to give you a number here. I just want you to put whatever the next serial value is for this thing. The nickname is going to be the nickname of this Pokemon. The HP is going to be the HP of this Pokemon. Sorry, the nickname needs to be put in quotes because it's a string. HP is a number, so we're not putting it in quotes. It's not a string. And then the trainer is the last thing that we need to have here for this. So I'm going to put this in quotes because our foreign key here is a string itself. And I'm going to just type this in, and I will add it in a moment. Pokemon are going to have trainers. We're going to put this trainer field onto this class. But I just want to have this query set up right now. The very last part of what I want to do with this is I want to say returning ID. So this returning part of my insert statement is the way for me to get back the ID that was generated by the database. This is how I'm going to ask the database to give back to me the information that it generated as a result of doing this insertion. So my full query here is insert into Pokemon. I've got the columns that I want to populate. All of these are the non-nullable fields that we have on this table. And I want you to generate the default value. I've got the nickname, the HP, and the trainer that I will eventually add. And what I want you to give back to me is the identifier that you generated as a result of inserting this row into the database. I'm going to move this back a little bit so we can see it all on one long line here. And then what I'm going to do is I'm going to have to actually work with the data that was returned to me. I have to get the ID out of the result itself. And so I'm going to say this, results.forEach. And what I want to get back from this is I've got a result that I want to work with. And then within the result, there are rows. And I'm only inserting one field into this. So even though I'm doing a for each here, I know that there's only going to be one. I could put like square brackets here on 0 if I wanted to do this. But I'm going to use a for each to do this task. And then within this, what I'm going to say is the Pokemon that I'm working with, their ID should now be equal to row at ID. And I can also console.log this. So I want to see what the output of this is. I'm going to use string templates again. And then the very last thing I'm going to do in this method is I'm going to return that Pokemon. So I'm making changes to the one that's been passed to me, but I'm also returning it. The effect is the same. Like in both cases, the effect is the same. We could argue that it's redundant for me to return this, but I'm just going to return it anyway. Yeah.
Like, why do we have looks for results?
The results just generally is always going to be, there are an array of results that come back from this exec statement. No matter what we do, there will always be an array of results. It may only have one element in it, but there's always going to be an array of results.
Like we're just expecting one.
We're only expecting one ID, yes. This loop will only ever iterate once. This nested loop structure will only ever iterate once. Okay. So the next thing I need to do here is I've got to add this trainer. I've got to add this trainer property to my class. And so I'm going to add this as a private instance variable. I'm going to call this owned by. I'm going to call it trainer because that's what I've got in my query already. I need to import this type. I'm never going to create an instance of trainer in this class, so I can just import this as a type. If I wanted to make an instance, I'd need to actually import the class to work with it. I need to initialize this in my constructor. And then the very last thing I'm going to need to do is I'm going to need to also initialize this when I create this instance of Pokemon. So I'm going to open up to the side here the place where I'm creating this Pokemon, which is in the trainer controller. And that's right here. And what I want to pass to this is going to be this dot trainer exclamation point. I promise that this trainer is not null at this point. If I'm at a point of being able to add Pokemon, the trainer is definitely not null. Yeah. Where would you be inserting the discriminator? It's going to be where you're inserting that specific kind of thing. In this case, there's no inheritance structure that we've got in this example, so there's no discriminator to insert. If you have like a class that's saving a kind of upgrade or a kind of product, it might be within each of those individual classes. You might have a common superclass that's able to know about what the discriminator value is for the subclasses. Well, so you might need to write this for each subclass because each subclass might need to have different properties than the parent classes. The parent classes can't necessarily know about what each of the subclasses have in them. If you're using inheritance, you can use abstract methods to be able to help you structure all this stuff out.
Say, instead of just a subclass and a subclass, if there are like multiple layers, this save function for like the bottom.
Which way do you think of your tree in terms of up and down? The most common superclass, I guess, could have a save method, and all of them will inherit that. You could also have the very bottom of the hierarchy have it, and have that save method just be like an abstract method that all of them implement. Yeah.
Subclasses. Do I need to insert default value for the other subclasses?
It depends on how you have structured your tables. So if you're going to use that one table for all of the different kinds of those things, then you'd have to know about all those things somewhere. If you have one table per subclass, then you don't have discriminator values anyway. It's just going to be you're inserting for that specific subclass. Okay. All right. Okay. So now that we've done that, the very next thing that I'm going to want to do is the method where we're actually starting to do adding to the team, the place where we're going to want to save the trainer again is after we've added this Pokemon to the team. So in add trainer here, this is our controller method. In add trainer, we were saving the trainer to the team. We were saving the trainer here, and this was because we had just created a new instance of this class. Kind of purposely didn't put saving inside the constructor of this class because there are going to be circumstances where we want to make an instance of a class without actually saving it to the database. But the place where I'm going to put persisting this Pokemon to the database now is not in the controller, but in the method that is adding to the team. So where I'm actually adding this Pokemon to the team for this trainer is where I'm going to do that. So I'm going to save my controller, and I'm going to open up my trainer class here. And the place where I want to save that, the trainer again is after I've done adding to the team here. In this case, I'm still just going to call that same method, trainer.saveTrainer. But this time I'm just going to save this. I want to save the current instance of this thing to the database. I'm going to scroll up just a little bit here. And here is where we're saving our trainer. And I'm going to give you a moment to take a look at this again. Just kind of remind yourselves of what we were doing. And I want you to try and identify if there might be a problem with this in terms of every time I add a Pokemon to my team, I'm going to save the trainer again. I'll give you 30 seconds just to think about this, and then we'll step through it together. Okay. Does anybody see a problem with this? If I save the trainer, I'm going to run this query again.
Like it is unique William Craft.
Yeah. So the problem that we've got with this is that our trainer name is a unique field on this table. So if I save this trainer again and again and again, and I insert the trainer, it's going to crash. It's going to fail that unique constraint. We'll get this unique constraint violation if we continue to do that. There are a variety of ways to kind of avoid this issue. So we could do conditional statements. We can ask, like, tell me what trainers are in the database or if one exists with this name already before you try to save it. So before you do an insertion. But what I'm going to do is this. I'm going to add to this statement an additional clause here. And the clause is called onConflict. So onConflict onConflict is a clause that we can add to our SQL insert statement that basically tells the database what to do when there is one of these unique constraint violations. The thing that I want to do with this right now is onConflict, I want you to do nothing. I actually just don't care. If I've reinserted this same trainer again, that's fine. That's fine because the trainer only has a name. The trainer actually only has a name in this table. So if I reinsert this value again, it's kind of irrelevant. I've just inserted the same value again to the table. So onConflict, do nothing here. If there's a unique constraint violation, don't do anything. Effectively just report success. You have inserted it because it's already there. It's already in the database right now. There are other things that I'll let you read about on your own if you want. I'll provide the documentation for this after class today, but on conflict, you can also say things like, instead of do nothing, you can update the other values that have been passed to this. So instead of doing an insert, you can do an update on the field that you've got here. But for us, for this, all we really want to be able to do is effectively say, just do nothing. I'm okay with this not doing anything. After we've saved the trainer then, the next thing that I want to do is actually then go through and save all of the Pokemon on the team. And so I'm going to say trainer.team.forEach. And what I want to do for each of these Pokemon is I want to save them. So I'm going to say Pokemon .save. I'm going to say this. I'm going to say Pokemon.save Pokemon. I'm going to pass that Pokemon to the save Pokemon method. But I also only want to save it if the Pokemon hasn't been saved before. And the way that I'm going to figure that out is if the Pokemon has an ID. So if this Pokemon doesn't have an ID, then I want you to save it to the database. If it does have an ID, then don't save it again. Only Pokemon that haven't already been saved to the database. Only Pokemon that haven't actually been inserted already, haven't yet been inserted, will have an empty ID field. So that goes back to here, where we're doing this for each and populating the ID from the insertion that we got back, the ID that we got back from the insert statement. The only time that that ID field is ever set by us is when we actually succeed with insertion. So I don't want to resave my Pokemon here, because if I did resave them, I just kind of keep on doubling up and doubling up and doubling up and doubling up all the Pokemon that I have on my team. Once I've got the Pokemon saved, so this is going to cause me to save my Pokemon, I also now need to be able to load them back from the database. I'm going to save all of this for now. And I'm going to go to my web browser, and I want to make sure that this behavior actually works. So when I'm loading this database up right now, the state that we're in, or when I'm loading this app up right now, the state that we're in is we're trying to ask if there are trainers in the database before we actually get a page to add Pokemon to the trainer. So if I say select star from trainer here, there should be no trainers here. And this is this dialog that's now popping up and saying you should create a trainer so that we can actually start doing something with it. I'm going to enter my name here. I'll be the trainer. I'm going to say add trainer to this. And now if I do the select star from trainer, I've got myself in here. If I refresh this page, I'm still in the database. Now what I want to do is I want to add a Pokemon. And so I'm going to say that I've got a Pokemon with initial HP of 12, and I'm going to add Charmy. So this is the Pokemon that I'm going to say that I got from Professor Oak when I started. I'm going to add my Pokemon here. And we've got a problem. So let's... Oh no. Okay, so let's try to figure out. Let's debug what's going on here. Here's what I want to do. I want to actually see what the SQL statement is that I'm trying to do. That's going to help me figure out what the problem is here. So I'm going to say this. I think I immediately know what the problem is. This is not a string. That's not a string. That's an object. Yeah. The unique value, the problem that we're actually seeing here is that it's violating this foreign key constraint. And the problem is that when I try to insert this value here, that as a string is not the name of a trainer. That's going to be an object that gets stringified in some unknown way. So this should actually say dot name, because this is what we're actually putting into that foreign key field. Okay, so I'm going to go back here. I'm going to try to add another Pokemon. Good, it worked this time. Okay, good. And we got this Pokemon got ID 1. So this is the very first Pokemon that was inserted into our database here. The state that we're in right now, though, is that if I refresh this page, I do get that this trainer still exists. It's still showing me the trainer view, but it's not loading the Pokemon from the database. I've persisted them. If I do select star from Pokemon here, that Pokemon is still there, but I just haven't loaded it when I got the trainer from the database in the first place. And so what I'm going to do is this. I'm going to go back to my code, and in the Pokemon class, I'm going to add another method. This one is going to have the responsibility of getting all of the Pokemon for a specific trainer. I want to be able to get a trainer's name and use that trainer's name to retrieve from the database all of the Pokemon for that specific trainer. So this will be a static async method. It's going to be called get Pokemon for trainer. I'm going to pass to this a trainer that I want to get the Pokemon for, and this is going to return a promise that is an array of Pokemon. So this is giving me the ability to get an array of Pokemon from the database for the specific trainer that I'm asking for here. I'm going to start writing this out. I'm going to say let results equal db await db.query. I'm asking for data from the database, so I'm using this query method. I'm going to fill in what's in the angle brackets in a moment, but what I want to get from this is I want to select the ID, the nickname, the HP, and the trainer from Pokemon, where the trainer is equal to, and then here's where I'm going to actually type in the correct thing. So that I'm actually going to type in the trainer's name here. So I want to get from the database the Pokemon that have the rows from the Pokemon table that have a trainer that is for this specific trainer that's been passed to us. What I'm going to put in between these angle brackets here is a description of the shape of the data that's coming back from this result. The shape of the data that's coming back from this result corresponds to the names of the columns and the types that I'm getting from each of those things. And this is just going to help so that when I'm going through and translating those values into instances of Pokemon, I'll be able to do that with TypeScript. So what I'm going to say here is that the shape of this data is that it's going to have an ID field, and that's going to be of type number. It's going to have a nickname field, and this is of type string. It's going to have an HP field. This is of type number. And finally, it's going to have a trainer field, and this is of type string. As we're pulling it from the database, we're getting varchar 255 here, so this is of type string here. The trainer fields, we're never going to use it really, but I'm selecting it just for the sake of selecting it and kind of populating this structure of what we're expecting to get back from the value. Once we've got these results, Then what I'm going to do here is I'm going to initialize all of the Pokemon. So I'm going to say let all Pokemon new array. This is what I'm going to eventually return. And then I'm going to say results dot rows dot for each. And I have to do the translation here. So if you think back to Comp 2450, this is kind of that dumb code where you got to write, you just got to extract each field and put it into another object to recreate that instance of an object. So here I'm going to say this, let Pokemon equal new Pokemon. And what I need to pass into this is the row dot nickname, the row dot HP, and the trainer that has been passed into this method. Because this is a Pokemon that was saved to the database, I also want to initialize the ID value. This is not something that I've been putting into the constructor because we want to be able to make instances of things that haven't yet been saved to the database. So I want to say Pokemon.id is equal to row.id. And then the very last thing I'm going to do here is all Pokemon.push, this one. And finally, at the end of this method, I'm going to have to return the team that I got back from the database for this trainer. So the method that we've got here takes as input the trainer that we want to get this data for. It's selecting from that table. It's using that value that's been passed to us as a field. So we're using that as part of our where clause to get just the things that we want to get from the table. And then we're transforming the results that we get back from this to the type that we're trying to rebuild here. Yeah.
Please repeat what returning keyword does.
Of course. The returning keywords, and I'm actually going to scroll up to this one here, because this is where it's actually useful for us. The returning keyword in the context of our statement here is insert by itself does not return anything. But a common thing to do with an insert statement is to insert something into a table that causes a value to be generated for us. So our synthetic ID on the Pokemon table, we don't set that ID ourselves. We're allowing the database to generate that for us. Insert itself does not actually return anything to us, so we have to ask for that value to be returned back to us. So what's happening here is we're doing this insert statement. I am going to populate one row of the table with the data that I have passed here. The keyword default is going to allow the database to just fill in whatever it should fill in for that. So we've declared this as a serial type column, so it's going to put the next value into that. And then the returning part here at the very end says, please tell me what that was. I don't know what it was because you generated it for me, so let me know what it was, so that I can do things like take that ID field out and put it into the domain model object that I've got here.
So does it mean results, stores, and one ID?
In this case, this is an array that contains an array that both of them have one element. There's only one result that came back from this insert statement, and that was, this is the value that was generated. If you have more than one value that's generated, which is possible, or if you have an update statement, you can say, I want to get back the values that were changed from this. It will return to you the values that were actually changed. But at least for us in this course, the typical use case is to get back the synthetic ID that we got. So while we've got this loop structure here, this nested loop structure, it's really only a one element array that contains one element. So it only ever executes once. Does that answer your question?
There is like a single ID. It's
The library that we're using returns results from the query and exec functions as an array of results. So I don't have much of a choice but to do that. I suppose I could say instead results at 0. I could write this because I know that there's only one thing that's going to be in there. And I could then write .rows at 0. This would functionally be the same thing, but it's inconsistent with what I've been doing with other results from the database so far. I'll leave this line here to say that these are functionally the same thing. Yeah. Yeah.
So without mentioning with the ID there, we can't ask to return it back to us.
Without saying returning ID, there are ways to get that value back, but this is the most straightforward way to get that value back.
Like in the list of values that we're inserting, like we provide an ID that we're inserting and then the default. Like if we don't provide that, it will automatically generate an ID. But like, why do we do it explicitly? Because we're using the return ID.
Yes. I have to have the field that I'm returning in the insert columns to be able to get it back. Yeah. Yeah.
So like, just to make this sense, we're allowed to have multiple objects that actually refers to the same object. So like we're creating new objects here. Like
Yes.
We're referring to something else. So like we can just have multiple objects refer to the same object. So we always need to use the ID when comparing.
When you have multiple different instances of the same thing, yeah, you'd want to start using the ID in your equality testing if you want to test for equality between objects, because that's going to be part of what they are. This is also an indicator to us that one of them has been saved and the other one hasn't been saved to the database. However, I am going to say that while I am returning this instance of Pokemon, it's still the same one. I'm not making a new instance as part of the insertion operation. The insertion operation is in the database. I'm never actually making a new instance of the Pokemon until I get to the point of this part here. This part here is where I would be like, we wouldn't be going through the path of adding to the team. We wouldn't be clicking that button to make a new instance. This is me just getting it from the database in the first place. So in that sense, there wouldn't ever be two instances of the same class that refer to the same object. They're just loaded in different ways. Yeah.
Also, like, are we expected to like reflect the ID in the domain model?
You should put IDs in the domain model where you are saying that you have a synthetic key, yes. Yeah. All right, any other questions about this? Yeah.
We save the trainer as well as the trainer already owns the Pokemon. So the trainer already exists in the database.
The trainer already exists in the database, yes. We're not saving the trainer here anymore, though. Here, we're just using the trainer's name as a foreign key value. So this is like the owned by field in the owned by column in the Pokemon table. Yeah, so in this case, I'm not updating the trainer at all. I am adding to their collection, but that's by inserting a row that has their name in it. Okay, all right. So now that I can get this team of Pokemon for this trainer, I actually have to load it when I'm loading the trainer up. And so down here, I'm in the trainer class already. And here's the spot where we're getting all trainers. So this is the method that's being called by our controller in the first place. I'm going to make some changes to this to now also get Pokemon for each of the trainers. I'm going to have to make a small change to the code structure that we've got now. And I'm going to have to, oh gosh, my typing here is not working for me today. I'm going to have to make changes to this specifically on this for each part. I can get into this a little bit later, but I'm going to change this for each part to be an actual loop instead of using for each. Just go with me, come along come along on this ride with me for a moment while I do this. So what I want to do here is I still want to iterate over this loop of things that have been returned to me. But I'm going to say this, for let row in results.row, results.rows. What I want to do is for each trainer, that I've loaded, I want to load the corresponding Pokemon on their team. So I'm going to load a bunch of trainers up. Our system is set up so that we can only ever have one trainer in this database, but we're going to load the trainer up, and then I also want to get the Pokemon that they have on their specific team. So I'm going to create this new instance of a trainer. I'm going to say let trainer is equal to new trainer. I'm going to extract this statement here out. So row.name. I'm going to put that trainer into this array of trainers. And then what I want to do is I want to say trainer.team is equal to await Pokemon dot get trainer get Pokemon for trainer, and I want to pass the trainer itself. This should be row of results. There we go. So as I load the trainers up from the database, we still have this select name from trainer. This is going to give me all of the rows in the database for all of the trainers that we've got. And then for each of the rows that we get back from that query, I'm going to create an instance of a trainer. So I'm going to transform it back into our domain model instances. And then I'm going to ask for that Pokemon trainer's team to be loaded into it. That's going to run this get Pokemon for trainer query. It's going to construct a bunch of Pokemon for us. It will return that array back to us, and then we will eventually return back to the controller. The reason that I'm switching from for each to for here is that the for each approach to doing loop structures, it's taking functions. The functions themselves cannot be async unless you mark them async. I'm just going with a regular for loop to avoid that entire situation. The overall approach to this is still the same as what we had before. So I'm going to go back to my trainer controller here. And if I go back to the constructor where we're getting all trainers, we're getting that promise still. So I'm calling this get all trainers. I'm getting the promise to come back from that. The promise is initially being returned here when I do this first await statement. And then we're going down to the .then part. So the await says, push this work off to the side and then continue doing other stuff. We get to this .then, and the .then says, okay, I actually need the result of that promise, so take that work off of the queue and start doing the work. Here, we're then going to start doing that work again, and we're going to iterate over this, and we're going to hit this point, and it's going to say, await, push this work off to the side. Something's going to happen in the background. We're going to return back to where we were before, but we were waiting for that work to be done. And so it will just immediately start executing this stuff again. We'll just continue to load up each of those different trainers here. So I'm switching to using this for statement here so that we can have this await statement inside of the loop structure that we've got. I'm going to save this. Here. And I'm going to go back to my page here. And I'm going to add one more Pokemon. And like kind of weirdly, we had two Pokemon show up here, but when the page initially loaded, we had none. And I'm going to take us back to one spot, which is in the trainer view itself. where when we had set all of this stuff up in the constructor here, our initial understanding and assumption was that Pokemon don't have any Pokemon. Trainers don't have any Pokemon when we first create them, which was fair. We weren't saving anything to the database at that point. And so the last thing I'm going to add to this is I'm going to say this dot notify in the constructor itself. The notify method is where we populated that list of Pokemon. So I'm just going to call that method to populate the list of Pokemon based on what it is that we've got. So I'm going to save this one more time. And if I go back to my web browser now, I'm going to hit refresh here, and it's going to load up the list of Pokemon that were saved to the database for me. Gesundheit. All right. This has been a real thrilling ride through like getting this feature set up. I'm going to pause here to see if you have any questions about the stuff that we've got set up in this. Yeah.
I'm not sure if that's possible, but like, would it be possible just to draw it on that tablet or something, like their classes and their methods and how they're interacting? Because like there are so many methods and I couldn't. Yeah.
Yes. So let's do it this way. Okay. All right. So our main entry point to all of this is in the trainer controller. This is where I'm going to start from in terms of kind of getting stuff set up. So we're starting in the trainer controller itself. And we're starting in the constructor of that class. So we're going to just pretend that main.ts is started and it's called a constructor for this trainer controller, and we're beginning to execute code in there. So in the trainer controller, I'm going to pop up to the top here in the trainer controller. In the constructor, we're starting to ask this question. Hey, please give me all of the Pokemon or all of the trainers that are currently in the system right now. So this is that promise that's happening on line 18. So give me all of the trainers. That's giving me all of the trainers that are currently in the system. In the trainer class, we've got this get all trainers method. It's going to load a bunch of stuff up from the database. So this is going to do select This is going to load all our trainers from the database and call constructors on each of those. And then it's going to ask to get the Pokemon for that specific trainer. So this is going to load up the team of Pokemon that we've got for that trainer. I'm going to go to the Pokemon class now, and get Pokemon for trainer is going to select that. I'm not going to write all this out again, but it's going to select ... from our Pokemon table. It's going to get all of the Pokemon that we've got for this specific team. It's going to construct all of those, and it's going to return that back to this get all trainers. And now what we're going to have is a trainer that has a team. And then we're in the trainer controller itself. We're going to make this decision that we're going to create this trainer view because there is a trainer for us to be able to do that with. That takes us to the trainer view itself, and we're going to build up that structure. And all of this is now the same as what we've seen before. So this is rebuilding that structure of what we've got. The state that we're at right now is that we're on this page. So after I've done that trainer view, we're stuck on this page right now. When I click on and release this Add Pokemon button, that's now going to start executing code back in my trainer controller. And the place where it's doing that is going to be in this add to team method. So I'm going to write the word click here. And this is now starting to call trainer controller. It's calling this add to team or the show create Pokemon view, and it's showing that dialog box. I'm going to start entering stuff into this dialog box, 12 and nickname of Pokemon. And when I click and release this add Pokemon button, the flow that's happening here is we're calling this add to trainer methods or add to team methods. It's calling the constructor on our Pokemon. And it's calling the method add to team on the trainer itself. So when I call this add to team, we're making a new instance of Pokemon. And then the trainer.add to team. Trainer.add to team is happening right here. And this is ultimately asking for us to put that Pokemon on the trainer's team and then resave the trainer again. So we're going to cause ourselves to resave the trainer that we've got. That takes us up to the save method here. We start to do this insertion, but we've added this on conflict do nothing. So it's going to just basically not actually do anything with that statement. And then for each of the Pokemon that we have on the team currently, we're going to ask for those Pokemon to be saved. If and only if they haven't already been persisted to the database. And the way we're making that decision is by asking, do they have an ID field that's set? So trainer.save will then also call Pokemon.save on the Pokemon that haven't already been saved to the database. Up here in Pokemon, we're doing the save trainer, save Pokemon methods. This will insert that Pokemon into the database. It's going to get back the ID that was generated by the database for us. It will populate that field on the Pokemon object, and then it will go back to the save trainer methods. The save trainer method is going to go back to the add to team method. The add to team method is going to go back to the view, and everything will kind of settle. The trainer will have notified the view to update itself and show the updated list of Pokemon at that point. Does that help kind of clarify things? Okay, awesome. Okay, all right. So I'm going to go back here. I'm going to go back to my slides. And now we're going to switch topics slightly. And what we're going to say is that Walter, with his lack of opposable thumbs, has shown up at my machine here, and I've left it unlocked. I've left my machine unlocked right here, actually. This is the spot that we're at. We're going to pretend that Walter can't read, so he doesn't know what the word REPL is, and he's not going to interact with our database directly, but he can read enough to know that he can click on Add Pokemon. Walter is going to be here at this Add Pokemon screen, and he is on the red team today. When I say red team, this is a convention. There's the red team and there's the blue team. The red team are the adversaries. They're the ones that are trying to break into your system, and the blue team is the one that's trying to stop them from getting in the first place. So we're going to say that Walter is on the red team here. And what Walter is going to do is he's going to start adding a Pokemon, and he's not going to try to do anything too bad with the HP. He's going to give the Pokemon some kind of HP here. And then what he's going to do is he's going to start typing into the nickname field here. What he's going to say is this. Franklin keeps talking about Bulby, so we'll insert Bulby here. But Walter also knows a little bit about how our app works internally because he's been sitting there watching us type it in this entire time. And so he's going to type in a little bit of code that looks like this. He's going to say, I'm going to insert Bulby, but then I'm going to put this single quote here. I'm going to type in some other arbitrary HP. I'm going to type in that Bulby should be on Franklin's team. He knows enough about this to start finishing out the SQL query that we're actually invoking here. And then what he's going to say is, well, I want to play this game. So he's going to insert into trainer a name, and the name that he wants to insert is Walter. Then he's going to say, well, I don't have any Pokemon right now. So what I'm going to do is I'm going to update Pokemon, and I'm going to set the trainer to be equal to Walter. I'm going to steal all these Pokemon. And then I'm going to delete from trainer where name is equal to Franklin. He doesn't actually want to play this game anyway. Walter also knows that he needs to end this with a comment so that whatever else is going to run isn't going to run. And when I click add Pokemon here, I guess awesome, like that's a really long, weird name for a Pokemon. But if I hit refresh, oh no, Walter has stolen my Pokemon. Walter has stolen my Pokemon. Walter has taken my Pokemon team from me. Now you can see the notes that I'm reading here. Walter has injected SQL into our SQL. SQL injection, this is enabled by us constructing strings from untrusted user input. This field right here, and even this field right here, ultimately are strings that we're just using to construct queries. We're building up strings with string templates here. And so what that means is that when I have a statement that looks like this, when I'm doing this insertion into my database based on input that I got from my user that is not necessarily trusted, this is expanding to something that looks like this. So Walter types in a lot more there than what I've got on the screen, but if Walter were to type in Bulby and then close quote here, sad face, update trainer, set name equal to Walter here, in that field, the string template that we've got is going to just expand into this other set of statements, as opposed to what we had actually intended to do. We've got to stop Walter. We can't let him do this. We can't let him just show up and start stomping all over our SQL and inserting his own arbitrary fields here. There are a few different options that we've got. One is that we could just limit input to a certain size. What I mean by that is we can say that nicknames can only be 5 characters long. So on the fields that we have on the page, we're just going to say the max input size for this thing is 5 characters. You can't ever have a Pokemon nickname that's longer than 5 characters. That's close to being consistent with the actual game. Another option is to sanitize the input. So what I mean by that is we're going to take the input and we're going to write some code that is going to remove characters that could be used maliciously. So in the example that we just did, that means that I could take characters and I could say, well, you just can't have the quote in your nickname. I'm not going to allow you to have that as part of what you want to insert into this. You just give up. Okay, I guess. And another option is to use query instead of exec. I'm going to open this. This takes us to the PG Lite documentation. The query method here is execute a single statement. So where we were using exec before, this allowed us to run an arbitrary number of statements. Query is only going to let us run one statement. If I have insert into, I can only run insert into. The problem with that, though, is that Walter still controls the stuff that we've got here. He's still able to control the inputs that we're providing to this thing. Limiting input to a certain size is not a good solution. Part of the problem with limiting input to a certain size is that Walter can't read, but if I were to inspect this element here, and I put this max size, I can just change it. I can just remove that constraint, and then there's no longer a problem there. Changing the value on the server side is still not going to help me because I can still have kind of override the size that I've got there. Sanitizing the input is something that is pretty typical, but it's not a good solution for a bunch of different reasons. One is, I'm sure you have all seen this before. You try to type in a new password and it says, no, you can't use these extra characters. You can't put quotes in it. This is why you can't put quotes in. That's a bad reason, though, because like forbidding special characters from fields like names is not okay. There are European names that I can think of that would use the standard ASCII alphabet, like Irish names that have O in front of them and then an apostrophe. There are European names that have symbols that are not even in ASCII. There are Asian names that have many symbols that are not in ASCII, and knowing what all of the characters that you need to remove is not going to be appropriate. There are symbols in languages, in indigenous languages in Canada that also have like apostrophes and numbers in them. You can't just remove arbitrary symbols from input. That's not a solvable problem. Giving up is not a good solution. Using query instead of exec is fine. Like that will get you so far, but it's still not going to work ideally forever. And so what we're actually going to do here is we're just not going to concatenate strings in the first place. We're going to let the database do this for us. And this is the best way for us to accomplish that task. Letting the database deal with it is basically to change the structure of what we're doing to use something that's called parameterized queries. This looks an awful lot like using the string templates that we were doing before, in that we're going to use this query method. We're going to have our SQL statement here. But instead of putting the actual value that we want to put in, we're going to use these placeholders. Placeholders that we're going to do are $. So this is a special character that's being used by our database. And then a number that represents a one-based index into the array that comes next. We're going to provide the values that we actually want to insert into the array itself that we're passing here. The difference between this and doing string concatenation with templates like we were doing before is that we're actually passing this query itself with the $sign to the database engine and the values separately. They are not being passed as one single thing. It's the database's job then to do its own internal work for doing things like how should an apostrophe actually be stored in the database? But it's explicitly not part of the query. The database knows that it's not actually part of the query. There's a great deal of stuff that we're not going to talk about here that you can find out when you get to the 4th year databases course about how this all works internally. But the idea is we're going to separate the values from the actual statement that we want to execute so that our database is able to make appropriate decisions about what the values are that it's supposed to implement. So I'm going to do this in one place. I'm not going to go through every exec that we've got in class, but I will post a version that has all of the execs replaced with what we've got. I'm going to go back to our code here. I'm going to expand this, and I'm going to take a look at the trainer part where we're doing the save trainer here. And so I don't want to use exec anymore, but I'm going to change this now to be query. So even though we're inserting something, I'm still going to use this query method. And what I'm going to change this to be is not trainer name, but rather $1. I can remove the backticks here because we're no longer doing JavaScript templates. And the other thing that I'm going to pass to this now is going to be the array of things that I wanted to put into those fields that I parameterized here. So the value that I wanted to put in here is trainer.name. I wanted you to actually take that value and insert it into this field. This solves that problem for us. We don't actually have to worry about SQL injection after we've started to use this idea of parameterized queries to be able to accomplish this task. All right. Is that okay with everybody? Good. This is a straightforward change, but it's something that is nice that we don't really have to worry too much about once we've started to use these queries. We don't really have to worry about SQL injection stuff. Okay. Oh no, Walter got our database anyway. He managed to get our database before we figured out that we needed to use these parameterized queries. He either figured it out before we did it, and when you're doing SQL injection, like we modify data in the database, but you can also extract data from the database as a result of this. Not just the data in the database, but you can get the entire schema out of this. You can start to ask questions of the underlying database engine. What are all the tables? And then tell me all the column names. And then you can effectively reconstruct the whole schema from this. Alternatively, he was able to get the data because he hit me over the head with a wrench or because he went to the server room and pulled the hard drive out and was just able to get his hands on the data that we've got here. How can we, before Red Team Walter got our database, protect the people that we're actually trying to do things to protect? I'm going to skip past this for a minute because the thing that I really want us to talk about here is we want to protect our data at rest. I'm going to revisit this next week, but the thing I want to focus on here is hashing passwords in the very last dying seconds of our class. Hashing passwords, the idea here is that unlike Comp 2140, if you've taken Comp 2140, we're going to use cryptographic hash functions. These are slightly different than the hash functions that you would have used in Comp 2140 for hash tables. Comp 2140 hash functions, they're all about uniform distribution of values across an array so that you can put them in and distribute your data uniformly. But they're related in that it's trying to compute a unique value given an input. But the big goal is that once I've computed this unique value, it's really hard for me to go backwards from that unique value. Hashing our database, hashing our passwords to put in our database is very much about I can compute the value that's in the database using this hash function given the password that's provided to me. But once I've got the database, I can't figure out what the password was if I only have the database itself. There are a bunch of different hash functions that we can choose from. There are hash functions that are called MD5, and you shouldn't use MD5. There's one that's called SHA-1, and you shouldn't use SHA-1. These are both broken. These are older hash functions where MD5, I think you can find a collision within a second on a modern computer. It's just not a good hash function to use for this. bcrypt, yes, maybe use bcrypt. And PBKDF2, this is one that I'm going to strongly recommend that you use here. This is recommended by the government of Canada, and a lot of other security organizations in the US are all recommending this. The idea is this. When someone is signing up for an account, they are providing to you a password. You don't take the password in plain text and put it in the database. Instead, you pass that through a hash function. It will return a new value to you. It's going to give you the hash of that function. You store the hash in the database. When the user comes back and they say, I want to log in again, you take their password as input and you hash it, and you compare that hash to what's in the database. So you're never comparing a plain text password to a plain text password. You're comparing hashed passwords to hashed passwords. So you never have their actual plain text password in your database. So Walter has hit me over the head with this wrench. He's got the hard drive. He's got the database, but he's only got these hashed passwords. So he doesn't know that you're all using password 1 as a password to log into Gmail. I'm going to have to answer your question after class today. Thank you all for coming along this really boring ride with me today. Like I said, I'll push this up to the course webpage, but at this point, you should be able to do lots of stuff with SQL and TypeScript. You should be able to use prepared statements, and I'll push that code up after class. And now you should also, at least beginning, be able to securely represent and store credentials for authentication purposes. Again, thank you for your extra time, and I will see you all